All right, here we go. So in this video, we are going to examine completing the square. And an important thing to note is that completing the square is just another way to solve quadratics. All right, another way to solve quadratic equations. Quadratic equations. All right, so say you can't factor, you don't remember the quadratic formula. Completing the square, you can use that, all right? But of course, if you can't remember the quadratic formula, completing the square can be a little bit tricky, but we're going to try and break it down and make it a little bit simpler for you. All right, so before we even get into completing the square, we need to learn how to extract square roots. And what exactly does that mean? In this case, if we're trying to solve for x, all we need to do is take the square root of both sides. All right, I take the square root of both sides. Obviously, square root of x plus 3 squared is just going to be x plus 3. And then you take the square root of the other side. One important thing to note is if that you initiate the square root, if you are the one taking the square root of the other side, you must do the positive or negative of that side. Okay, the positive and negative of that side. So square root of 16 we know is 4. So now we have x plus 3 is equal to the positive or negative 4. Okay, positive or negative 4. And so then x equals, well, I'll subtract 3 over. So negative 3 plus or minus 4. Negative 3 plus or minus 4. Negative 3 plus 4, obviously, is going to give me 1. Negative 3 minus 4 gives me negative 7. So these are my two solutions to the quadratic. X equals 1 or negative 7. You can plug them both back in. If you plug in 1, you get 4 squared, which equals 16. Yup. If you plug in negative 7 plus 3 is negative 4. Squared is 16. So both of them work. And of course, we can see that's why you have to do the plus or minus, because a negative number squared is positive. All right, so now we're going to take a look at the reverse of completing the square. Because our goal when we're completing the square is to get it to look something like this. Okay, to get it to the point where we can just extract square roots. So we will have x plus some number or x minus some number squared equal to some other number. Okay, then we can just square root both sides, subtract a, and we are done. So we need to examine, well, how exactly do we get there? We need to complete the square in order to write it in this form. So let's look at the reverse of that. If we have x plus a squared, that's the same thing as x plus a times x plus a. And if we FOIL that out, that's x squared plus ax plus a squared. So we wind up getting x squared plus, well, ax plus ax is just 2ax, and then plus a squared. So our goal, if we get something to look like this, then we can just write it as x plus a, the quantity of x plus a squared. So our goal is to make it look like this. So what does that mean? Let's say we have x squared plus 6x. And we know that's equal to 0. Well, what does it mean to complete the square here? Well, we can look here and obviously tell we're missing this a squared term. That a squared term is really what we need. So I need to add some value so that I can complete the square. Well, I can see that my b term is supposed to be equal to 2a, right? My b is equal to 2a. In this case, 2a has to be equal to 6. So if 2a is equal to 6, then that tells me a needs to be equal to 3, and therefore a squared would be equal to 9. So I would have to add 9 in order to complete the square. And of course, whatever you do to the left side, you have to do to the right. So I add 9 to the right. And now I can take everything on the left and I can turn it into this squared, right? X plus a, which in this case, a is equal to 3. So that is x plus 3 squared equals 9. All right, and then we would just extract square roots to solve from there. So we get x plus 3 is equal to square root of 9 is 3, and of course it's positive or negative. So x equals negative 3 plus or minus 3. X equals negative 3 plus 3 gives me 0. Negative 3 minus 3 gives me a negative 6. All right, so that is how we use completing the square. That's how we use completing the square. Obviously, in this case, x squared plus 6x equals 0. It's probably easier just to factor, but I was just using this example so we can see, all right, how do we complete the square? So let's take a look. We're just going to practice here on completing the square on each side. So all you need to do is take that b term, divide by 2, and square it. So 8x, if we divide that by 2, that's 4 squared, gives me 16. And then that's just equal to x plus this b value divided by 2, so 4 squared. X plus 4 squared. Here, I'll divide 9 by 2, so I get 9 halves. Okay, 9 halves squared is going to be 81 over 4. Okay, right, 9 squared over 2 squared. And then this is just going to be x minus 9 halves, right? I'm just dividing this value right here by 2. So x minus 9 halves squared. And for this last one, take this, divide by 2. So 14 divided by 2 is 7. Squared is 49. So this is just x plus 7 squared. All right, so that's how we complete the square. We just take that b value, divide it by 2, square it, and we'll add that. And then it's just x plus a squared. So let's take a look at a couple of examples. Here I have x squared minus 12x equals 13. So I'm going to take negative 12, divide it by 2 gives me negative 6. I'll square it and get 36, and I'll add that to both sides. So x squared minus 12x plus 36. Obviously, whatever you add to the left side, you must add to the right side. So 13 plus 36. Now I can just take this left side and write it as x. Then I'll take my b value divided by 2. Negative 12 divided by 2 is negative 6. So x minus 6 squared has to be equal to 49. And now I'll just extract square roots. So x minus 6 equals positive or negative. Square root of 49 is 7. So x equals 6 plus or minus 7. 6 plus 7 gives me 13. 6 minus 7 gives me negative 1. So x equals 13 or negative 1. Again, in this case, guys, we definitely could have just subtracted 13 over to the other side and factored, but it's easier to show this using kind of simple examples and examples where my answers are going to be integers, right? Like whole numbers here. Because that's just easier to show you. This next example, that's not going to be the case. You would not be able to factor. So let's take a look here. Looks complex. Okay, let's get everything to one side. So I'll subtract everything over. I get 4x squared minus 20x, and then plus 17 is now equal to 0. All right, so I want to, let's just get rid of this 17. I do not want it as the same on the same side as my x's. All right, so I'll subtract that to the other side. 4x squared minus 20x equals a negative 17. Now, an important thing, whenever we're trying to complete the square, my a value must be equal to 1. My coefficient of the x squared must be equal to 1. So I'm going to factor out a 4. So factor out a 4. This is now x squared minus 5x equals negative 17. I'll divide that 4 over. Equals negative 17 over 4. Because now I have just like that x squared plus bx by itself on the left side. So now I can complete the square. So negative 5 divided by 2 squared is going to give me 25 over 4. All right, so I'll add that to each side. So I have x squared minus 5x plus 25 over 4 equals negative 17 over 4 plus 25 over 4. All right, so now on the left, I just completed the square, so I can just write this as x plus a squared. Remember that a is just my b divided by 2, so x minus 5 halves. X minus 5 halves squared. If you FOILed that out, you would get this right here. Okay, you would get that right there. And that's going to be equal to, well, negative 17 fourths plus 25 fourths is positive 8 fourths, which is 2. All right, I'm going to erase this stuff on the side here. I'm going to take this. I'll even change color so we can see where we're going next. Let's go red. Okay, I'll extract square roots. So take square root of both sides. I have x minus 5 halves equals the positive or negative square root of 2. We cannot simplify, so we'll just leave it as square root of 2. Then I'll just add the 5 halves over. 5 halves plus or minus the square root of 2. Now, you can leave it just like this. This is definitely a correct answer. You could split it up and say x equals 5 halves plus root 2 or 5 halves minus root 2, but you don't need to do that. You can just leave it as plus or minus as long as you understand that means 5 halves plus root 2 as well as 5 halves minus square root of 2. All right, so we're completing the square here. We start just by trying to get the x squared plus bx by itself. We complete the square by dividing by 2, squaring, adding to both sides. And then we'll just extract square roots from there.